Hi, I'm Mike McGrath from Semantrix. This is a presentation on our HSR, Health Sense and Respond derivative of our Semantic Fusion Situational Awareness core. We see this as applicable to hospital environments, also potentially to battlefield triage models. It's intended to be an action support system for nurses and other medical staff. And this presentation was actually done in combination with a live demo at the HIC/NIC 2012 conference in Sydney earlier this year in August. So, a little bit of background around our system. HSR was doing more with less information was the key to the conference. The HSR is what Semantrix believe medical decision support will look like over the next decade. Active monitoring of patient location, information dissemination to staff through smartphones, iPads, mobile devices, making available their current patient state, the scheduled treatment plan, the diagnostic results in real time. Again, high quality relevant information made available to staff next to the patient, i.e. literally next to the patient, will be translated to more informed decisions and delivering better patient outcomes. Now, how we see this working, managing today's hospital workload, people focus on 3 to 5 things. A busy nurse might have 50 activities at one time to keep on top of. Next generation action support or decision support can handle thousands of things at once, can focus and give you context-aware information, just the information relevant to your patient, to your role. Physiotherapist gets the results of the exercise program. OT gets the results of their activities that they've requested. A nurse gets handover information from the previous shift. Doctors get the summary of the patient in terms of their overall performance over the last 24 hours, 48 hours, previous activities in other hospitals. In future, it's got to be decision support must be real-time, location-aware, identifies where the patient is so you can manage movements and optimize your workflows, monitors patient sensors and trends. So we know there's a decrease in oxygen saturation. We know the blood pressure's gone up. We know there's some other niggling problem that's getting worse, and notifies patient in real time of issues ahead of time where we can. And we centralise patient info so everyone has access to it at the level required with their level of access control. A nurse sees what's relevant to a nurse, a doctor sees what's relevant to a doctor. Again, portable device and location awareness are key. And we see real major real-time location aware decision benefits to patients, nurses, doctors, other staff members. So smart health system benefits, patient behavioural monitoring. There's some key areas here which we think will benefit patients dramatically. 3D vision sensors, so we can monitor the patient's status, their activities and their behaviour. They've exercised for 15 minutes, they're unstable on their feet, they're standing up, and we need to have someone come and help them straight away. That ties into falls detection and prevention. Again, if you can pick up typical behavioural and postural patterns which indicate an unstable patient has a high falls risk, you can send help to stop that fall occurring. And we can do that with non-contact 3D vision systems from PrimeSense, the people behind the Microsoft Kinect sensors. And again, with the combination of NSE, RFID, and Zigbee wireless mesh communications. As an example, you can track and monitor patient activities, how far they've walked, where they are, trigger off someone to bring them back to their room as required. You can see what they're doing at night because a lot of these sensor systems are either non-contact or infrared capable. So you can actually tell if a patient's gotten up at night, they're wandering around the room, they're trying to find a toilet. This may not be a dramatic thing, but it can save you an awful lot of time in terms of the subsequent side effects if they're not able to make the toilet in time. Next thing, again, we see NFC wrist tags. We've built prototype systems which will take patient information tied to that tag, validated with biometric information, and allow you to verify the patient, to look at their current treatment timeline, to validate staff, and also with a swipe of a phone, tell exactly what that patient's problems are, what the treatment program is, where they should be at a particular time. And we can also do what I class as coincidental optimization. HSR knows what's happening in terms of a timeline of activities. A patient should be getting ready in the morning at 8 o'clock to be ready for an X-ray at 9 o'clock, to then move on to their physiotherapy program at 10:30. So if we know where a patient is, i.e. they're outside, they're in an area talking, they're having a cigarette, not that they should be doing that, then we can have the nearest resource, i.e. a staff member, give them a nudge at 8:45 saying you need to be back at your room at 9 to be getting ready for your x-ray at 10. So again, coincidental optimization is making use of the resources you have, 100 staff members, 200 patients, making use of them at the optimal time because you know where people are located. Again, real-time sensor information and distribution. We can dynamically collect and dynamically publish. It's a new technology, only become available in the last year or two. And our partner companies are heavily involved in this. We can automatically analyze using text analytics, metadata tag, and dynamically publish all information relevant to a doctor, to a patient, to a nurse, and integrate all that in terms of time, their treatment timeline from admission all the way through to their final release from your area. Again, mobile information access, not through a computer terminal, but through a secure mobile device using fingerprint recognition, facial recognition, voice recognition. And again, context aware, given I know who you are, I can make the right information available. And we can also analyze using text analytics, SNOMED CT, and a range of other life sciences databases, i.e. one of our partner companies, Ontotext, have 20 life science databases, including SNOMED integrated. You can then start to take into account that it's a 47-year-old female patient with a certain set of conditions, and these are her current treatments and any contraindicators which may be there at that point in time. We can also analyse diagnostic reports for keywords and flag that there are critical things which need to change. Again, we've mentioned new types of wireless tags, the multi-tag concept, combining all of those, swipe the phone on or near the patient wristband, immediately get all their information on the phone. RFID tells you where the patient is within a room. A Zigbee wireless mesh can locate a patient within half a metre within a hospital ward if it's appropriately instrumented. 70% of mobile devices will be NFC and RFID enabled within 2 years. And again, the multi-tag concept allows you to actually bi-directionally interact with patients, beep them, page them, use it as an emergency call button. These are all useful activities, but also give you much better visibility of patient location and therefore your ability to help them. Mobile devices, again, we can overlay diagnostics and x-rays using augmented reality, see where the break was on the arm, see how things are progressing. Again, additional information handover comments can be overlaid over the patient when you're looking at them having to swipe their tag or looking at them through the camera. We can also make that treatment timeline information available to you through that mobile device. One of the key areas we see moving forward is patient behavioural monitoring, as we said, using the Connect type sensors, analysing a body model, having a database of postures and behaviours over time, i.e. making this a behavioural time-based recognition model. We can indicate whether a patient's a false risk, whether a psych patient's agitated. We can tie that with facial recognition, confirm identity. We can tell you whether the patient's lying on the floor or lying on the bed, whether they've just fallen, whether they're carrying out their exercise program, all useful information. We mentioned the treatment timeline. Now, this is how to tie patient health records into dynamic publishing models to automatically aggregate all the information on a patient, filter it and structure it according to your role and the context. I'm a doctor, I want the summary of my prescriptions and my recommendations available in a standard format on the device at that time. I'm a physiotherapy, I want to see the results of the patient exercise program, what was prescribed, what they've actually done. Again, integrating the 3D monitoring with that means I will know what they've done over that period. And I can publish this automatically. So there's no major workflow requirement. We can just make this information visible to a person in a time frame. So as an example, from admission, what's happened on admission, what the activities were, i.e. operations, how they've been managed in terms of treatment, and what the release model is moving forward. And again, you can filter that information any way as required. Now, in context of HSR, we integrate that with a rule-based model. So because we have activities which tie into real-time sensor monitoring, we can be looking at blood pressure and O2 sensors. In the case of an O2 fall, we'll trigger off one activity. In the case of another baby, as this example shows, in the case of an O2 and a blood pressure call the nurse. But if we have a significant O2 and blood pressure drop, call the nurse and a pediatrician immediately. that baby may have been born prem and may have heart problems. We've built this into a visualization, a sensor simulation, which we'll run up as a separate demonstration. But we've got some rather interesting ones. So again, we have our example of babies. We can do more with that information because we've now got the simulated ward. We can tell where people are. We can optimize who attends a patient at a particular time. So the closest doctor or the nurse in charge of that particular patient, if she's not available, another nurse who's also been assigned to that patient in case the first nurse is not available. We can bring the closest doctor. If no one's available, bring the person with the relevant experience in real time if there's a problem. And again, as an example here, we have in our real-time demo an example of Nurse Eames, who's been allocated the Prem Baby Ann and also John Doe. We have the status available on that patient at any time. We can't tell where Harry was. He's missing at that point. John Doe has an ECG alert, and that's going to trigger off a you must respond or nominate someone else. If no one responds in a certain time, the system would automatically escalate to an alternate nurse or a doctor and then further up the hospital hierarchy because the system is organisationally aware. And again, we have an emergency situation for John Doe. If we drill down to that exactly, all of the sensor information is made available. Another example would be if, again, we've had the myocardial infarction. John doesn't respond appropriately, so we have to trigger some support for him straight away. We could have an elderly lady. In these examples, we have a Connect sensor monitoring the room. If the person's unstable, call a nurse. If the first patient falls, call a nurse and a doctor because that patient was a falls risk and has probably broken a hip. We can also indicate whether an unauthorized patient has entered the room because we have a 3D sensor with facial recognition, RFID tags, and we can tell that a person without the appropriate tagging has entered the room at that time. We can have an elderly patient wandering and immediately trigger off a response if they've moved out of a room. But we could also trigger off a security response if this person is potentially dangerous, if they're angry or upset. We can have a psych patient and we're monitoring whether they're agitated and bring the nurse and security in that case as a safety measure. So look, in general, we see HSR as being a way to have real-time decision support, integrate real-time sensors, geographic location, knowledge of the patient conditions, knowledge of the treatment programs together to optimize workflows in the hospital, to optimize patient care, and to provide the best quality patient support that nursing and medical staff can potentially provide. So again, as we think this translates, high quality real-time information made directly available to medical staff translates into more informed decisions and better patient outcomes. So with Semantrix, the future is not far away. Thank you. And we'll provide an additional set of example and demonstration visualizations in a separate video file. Thank you for watching this.